Okay, Chris Chinnock here for Display Central. I'm in the Flight Safety booth at ITSEC 2013 with Terry Lin. Terry, what is your title?
I'm a Senior Staff Display Systems Engineer.
Great, thank you. What we're showing, you're showing today, and in back of us here is a really cool looking collimated display. This is a 3D display. And what's the field of view on this?
It is 140 degrees horizontal by 55 vertical.
Okay. So tell me exactly what how is this set up? You've got an IG and the projectors. How's this all being set up?
Well, we've got four Christie WQXGA Mirage projectors, and they're running stereo, and they're driven by 8 channels of our IG.
8 channels, okay. And each of those channels is running at 60 frames, right?
Yes. Okay. And it's our new Vital 1100.
Vital 11, right, which we just talked about. Okay. Now, as I understand it, because you've got the 8 channels going to 4 projectors, each one is delivering 60 frames, but those are then interleaved in the projector to create a 120 frame update.
Yeah, that's where it creates the left eye and right eye. That's all done in the projector.
Gotcha. Okay. So when we were in there before, this is tuned to a very nice eye point, and you can obviously put on the glasses. You've got a very nice perspective. You're showing Ariel Refueling, which has been an application people have been talking about for quite some time as a realistic 3D application for simulation, because frankly most aren't 3D applications. Correct?
That is correct. The 3D adds a lot more depth cues for a boom operator trainer, and the collimation. The boom operator is focused on the end of the probe, which is around 60 feet away. So the collimation actually gets it out to that near that distance, and then the stereo allows them to get the depth cues they need to adjust.
To do the process,
yeah. Yeah, to do the task.
Now, one thing I noticed when you look at this, the images that you were showing with that boom operator training, is you've got a very nice perspective of the ground below. I really felt I was at altitude and looking at the ground. And I could see the boom in 3 dimensions for sure, and it has depth, but what I didn't get was a good feel of how long that boom was. If you told me that was 24 feet, I'd have believed you, but even though it was 60 feet. So maybe, and we had talked about this offline, having a reference frame there would have helped with that depth perception, perhaps.
Yeah, absolutely. If this was a real trainer, we would have had a physical aperture that would replicate the aircraft, so that they could actually have the physical reference surrounding the display system.
Gotcha. Okay. Now the other innovation that you're showing here is this glass spherical mirror. A lot of collimated displays are also made with mylar, but you've chose to use glass. So tell me why and how that's. Why glass versus mylar?
Well, glass offers several benefits that film does not. Because it is a rigid mirror, it does not have the typical mirror distortion that's associated with film mirror. Plus, since it's separate segments, we can extend that field of view all the way up to 300 degrees without no problems, whereas film collimators are typically limited to 225 degrees.
Okay. And we were talking earlier about the cost differential between your glass mirror system versus a mylar system in the 225 degree range, and you said it was about only about a 10% premium for glass, correct?
Yes, very competitive with film.
Okay. Great. Any other points we haven't discussed you want to talk about?
No, that's good.
That's it. Okay, great. Thank you, Terry.
Thank you.
Chris Chinnock for Display Central.